Hello, and welcome to a little video about the Unit 1 test review. Let's get started. The first thing that we're going to do on this graph is identify the domain and range. Just to remind ourselves, the domain is our x's and the range are our y's. Our x's go from left to right, our y's go from bottom to top. So that means we need to find the left and right side of our graph as well as the bottom and top. Let's check it out. There we go. The left side of my graph, is right here. It happens to be at 0. The right side of my graph is right there, and that ends at 10. Let's write that in. For our domain, we start at 0 on the right and at 10 on our left. For our range, we're going to go from the bottom of our graph to the top of our graph. Now, I don't mean just looking at the numbers. I'm talking about that red line. For you on your paper, it's probably a black line, but for me, it's red. That's the graph I'm talking about. The bottom of my graph, the lowest it goes, is right here. It also happens to be the left of my graph, so that's the bottom. And then this is the top of my graph. So my graph ends at 8, which means our range is from 0 to 8. For letter B, what we're going to do is include the intervals where our graph is increasing, decreasing, or constant. Well, we have 3 intervals on my graph, so I see 3 different parts to it. The first part I see, and I always start from left to right, is this one. This is increasing because it goes up. So let's write that down. We're increasing. Now, when we talk about the intervals, we're looking at the domain intervals, which means we're looking at the x's. Well, it looks like I start at 0 and then I finish increasing. Oh, I don't mean to select that. Hold on. Technology. Malfunction. Whoa. I scrolled down by accident. Alright, so we start at 0 and it looks like we end at 4. So we go from 0 on the domain, so our x's, all the way to 4. Next we have this flat part. That is called constant. So I'm going to write, what does it keep selecting? Hold on, 1 second. Oh, I see. No. Boom. That should be better. Okay, so constant. We start being constant where we stopped increasing, so at 4, and we're going along the x's. We finish being constant at 7. Let's take a look at this last part. What's happening there? Are we increasing, decreasing, or constant? It looks like we're increasing one more time. Let's put it down here. I for increasing. We start increasing from 7, and we go all the way to the end of that line, which ends at 10. Let's try that one more time with number 2. First, I'm going to write down that my domain and range are x's and y's. I like to fill that in first. X, y, and our inequality symbols. X goes from left to right, and y for our range goes from bottom to top. Let's check it out. Let me zoom in a little bit. Okay. The left side of my graph once again starts at 0. On the right, I end at 16. Notice how my graph keeps going. I could have gone all the way to 18 here, but we ended at 16. The bottom is right here at 0. The top of my graph is at 14. Next, let's do our intervals. All right, let's check it out. I see 3 intervals. We are increasing, then we're, uh-oh, that did not help, apparently. Oh, there we go, did it? No. Why does he keep doing that? Who knows? But we're constant, and then we're increasing again. Let's write those intervals down. First, I'm increasing. Remember, we're using the domain. I start at 0 on the x's, and then I finish increasing at 10. Next, we're constant. We start where we finished at 10, and where do we end? At 12. The last interval is increasing one more time. Let's put you down there. We start increasing at 12 where we finished being constant. And we're done increasing at 16. All right. In numbers 3 through 5, what we're going to do is determine whether or not these relationships are functions. And we'll write down why or why not. Let's start with this one. This is a graph. In order to see if a graph is a function or not, we are going to draw a vertical line for the vertical line test. If my vertical line, which is a line that goes up and down, if it crosses our graph more than once, it's not a function. And by graph, I mean the drawing, the curve, the line, not the graph paper. So this pink colored U. All right, I'm going to draw a vertical line. And that line crosses that U shape twice. Not a function. Explanation. Crossed vertical line test twice. In number 4, with a table, we look at the x's, at the domain. The domain is the only thing that matters. The range, the y's, they're important too, but in order to determine whether they're a function or not, I'm not even paying attention to them. Now the rule here is that the x's cannot repeat. Our domain cannot repeat. So, is this a function? It's not, because of these negative 5's. So what we write is the x's repeat. You could also be more detailed, and you can say the negative 5's repeat. Either way works for me. I also like when you draw that line for number 3. I like seeing it, and I like when you circle those x's for number 4. That repeat, that kind of shows me your understanding as well. Number 5 is a map. We have inputs and outputs. The rule is we can only have one arrow leaving each input. So I'm going to ignore these outputs. It doesn't matter how many arrows hit him, as long as only one arrow leaves each input. So is number 5 a function? Yes. Explanation. Only one arrow leaves each input. Okay. For number 6 through 10, we're going to identify the domain and range of both, of each relation. Okay. That means they might not be functions, and that's okay. They're relations, they have domains, they have ranges. Now the way we do it for things that are not graphs, like in number 1 and 2, is we write out a list using numerical order from smallest to largest, and we're also going to use squiggly brackets. So let's start with number 6. I'm going to write D for domain, and those are x's. We're going to write them from largest to smallest, from smallest to largest. Oh my goodness. It actually looks like they're in order. So I got -6, -3, 0, 3, and 6. Our range is our y's. Cool, looks like those are in order too already, so let's just write them down with commas in between. -3, -1, 1, 3, 5, and squiggly brackets around both sides. Number 7's the same idea. Now I know I'm not asking you this on the problem, but since I got you here on the video, number 6, is it a function or not? Think about it. It is a function. All the x's are different. They do not repeat. It doesn't matter that the range, the y's, had a -3 and a 3. All that matters is the domain, the x's. Whoopsie doopsie. Let's go to number 7. If it will allow me to scroll, be kind to me, OneNote. Please? I don't want to restart this. It's been 11 minutes. It's going to happen. Hold on. I'm going to click this button, and then I'm going to go like this. Yes. Perfect. All right. Thank you, OneNote. So, number 7. Let's start with the domain. That's our x's. I'm going to write it down here. D for domain. Looks like they're in order. Awesome. Make sure to write commas in between each number and squiggly brackets around them. Next we have range. Our range is our y's. Looks like they're in order too. Let's just write them down. 5, 7, 13. Close our squiggly. All right, off we go to number 8. All right, here's a table. Our domain is our input. And our range will be our output. So they're all synonyms. Range, output, input, X, Y, independent, dependent, all those things. All right, looks like they're in order again. How lucky. So we're just going to rewrite them as a list with squiggly brackets. 3, 4, 5. Oh, do you see how these 4's repeat? Not a function. We don't need to write a 4 twice. We're just going to write it once. Rude. We're just going to write it once. So what other numbers do we have left? Oh, just 10. Oh, okay. I need to use the mouse pad again. Whoa. Okay, here we go. Range. 0, 7, 10, 14, and 25. Now, mathematicians actually, when they see sets of domain and range, whenever you see a domain that has less numbers than the range, it's a giveaway to mathematicians that that's not a function. It's just a relation. Ooh, another table. For our domain, we're going to look at our x's. Oh, yeah, you can't see that. There. And for our range, we're going to use our f of x because f of x and y are the same thing. All right, let's write the domain in order. 0, 3, 5, 7, 9. Ooh, comma and squiggly. Same with our range. 2, 5, 6, 10, 12. Squiggly. And last one, I believe. Let's do number 10. Bing, 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 bing. All right. This is a set of ordered pairs. See how they also have squiggly brackets? Because that means set. Our domain is our x's. In ordered pairs, it's x comma y. So we are going to be looking at every single x. Let's put them in order. 4, 6, 7, 11. Our range is going to come from our y coordinates. I'll highlight them to make it easier to see. And let's write them in order in a list. 1, 2, 3, and 7. Ooh, we forgot to see whether or not 9 and 10 are functions. You see how number 9 I have f of x? That's a giveaway that that's a function. In number 10, do our x's repeat? They do not. It's also a function. Okay, not too bad. So that's essentially how the test will look like. Shorter, much shorter than this. I gave you some extra practice problems, but that's how review works. If you have any questions, please make sure to let me know, or whoever your teacher is, or whoever is helping you with math know. And have a good rest of whatever day it is for you. Bye!